Okay, so this is Math 1430, exam number 2, review. Our exam again is Monday, October 19th on WebAssign. Here's the question. Find the absolute maximum value. Value meaning y coordinate. And the absolute minimum value for this quadratic function on this interval.
Closed interval
It's a closed interval.
because of the square brackets.
So in other words, normally the domain is all real numbers, but with this problem, we have a restricted domain. So for our solution to find the absolute maximum and minimum, we're guaranteed, by the way, we will have an absolute maximum and minimum value because this function is continuous on a closed domain, closed interval. So here's our solution. Whenever you want to find absolute extrema, there's two things you got to do. The first thing is you want to find the critical numbers. And how do you find the critical numbers? By finding f prime of x. And make sure when you get your critical numbers, it's inside this interval. For example, if I get a critical number of x equals 4, that's not in the interval because it only goes up to 3, from -2 to 3. So if I had x equals 4, I would have to reject that critical number because it's not in this interval. Okay, but that's not the case for this problem. So let's find the derivative. What's the derivative of the given function f of x? It's going to be 2x minus 2 minus 0. So here it is. F prime of x equals 2x minus 2. So once you get your derivative, to find the critical numbers, there's two things you have to do. First, see where is this derivative undefined. And whatever x value the derivative is undefined at, that can be a critical number if it's in this interval. But in this case, because this is just a polynomial, it's never undefined. By the way, I'm using raw pasta noodles for a pointer. Okay, so this derivative is never undefined. I can input any value of x I want. The domain is all real numbers for this derivative. So therefore, there are no critical numbers by looking for where the derivative is undefined. Okay, so what's the other way to get critical numbers? By setting the first derivative, setting it to 0. So that's what I did here. I set the derivative equal to 0. And when I solve this equation, 0 equals 2x minus 2, that's the same thing as saying 2x is equal to 2 and x equals 1. And now, is x equals 1 in this interval? Yes, it is. So that's why I boxed it. So x equals 1 is a critical number. Note it is inside the interval, so accept. Okay, and now, because this is an absolute problem, you always want to input, besides the critical number, x equals 1, into your original function. But as well as inputting the critical numbers, you must also input the endpoints of the interval, which is x equals -2 and x equals 3. Here's the interval from x equals -2 to x equals 3. So with absolute problems, always input your endpoints into the original function. So that's what I did here. So we're going to input x equals -2 and x equals 3 into f of x, as well as the critical number x equals 1. So make sure you go to f. Don't go to f prime. Go to f. That's why I wrote this big note here, not f prime. You're going to input the critical numbers and the endpoints into f of x. The most common mistake with this problem is to input them into f prime. But I want to see the points on the graph of f, which is the maximum point and which is the minimum point. So you go to f. Okay, so what is f of 1 equal to? So make sure you go to the f of x function right there. And f of 1 is going to be 1 squared minus 2 times 1 minus 3. So that's what I have here. F of 1 is 1 squared minus 2 times 1 minus 3. That simplifies to 1 minus 2 minus 3, which is a -4. And then I want to compare all these values. Notice this is my input. When I input x equals 1, I output this y equals -4. So this is called a value. It's a y coordinate of the point on the graph. When I input -2 into my original function, I get this, which equals this, which equals 5. And then when I input my other endpoint, f of 3, you get 3 squared minus 2 times 3 minus 3, which equals 9 minus 6 minus 3, which is actually 0. So once you get your y coordinates, your values, To find the maximum value, all you do is ask yourself, what's the highest number you see? Well, 5 is the highest number I see. So the maximum, or I should really write absolute, the absolute maximum value is 5. Just write 5. And what is the absolute minimum value? Well, what's the smallest number here? Well, this is the only negative number, so this is the smallest. So the absolute minimum value is -4. And here's a graph of our function f, which this is just for fun. So here's a graph for fun. I didn't really have to draw this graph, but on the interval from x equals -2 to x equals 3, so notice I didn't draw the full parabola. You can only draw the part of the parabola from x equals -2 to x equals 3. Can you see how the absolute minimum occurs right there? And what is that absolute minimum value? The y-coordinate, -4. And what's the highest point on this curve with the restricted domain? At the endpoint, So what's the absolute maximum value? 5, the y-coordinate. So this graph is f of x equals x squared minus 2x minus 3 on this closed interval. Don't continue the graph because this part is not in the domain, because everything to the right is going to be bigger than 3 for x. Okay, I think that will cover it. So here I am, in case you forgot what I looked like. Here's my pointer, and have a good weekend, everyone.